Alright, so for today we are going to discuss or talk about the introduction of fluid mechanics. So basically, I would just like to share my screen first. Okay, so introduction to fluid mechanics. So basically our subject. No? So what is this introduction to fluid mechanics? So basically, let us get to know what is fluid mechanics first. Alright, so fluid mechanics is a branch of physics that studies fluids. When we say fluids, it might be liquid, no, gases or plasmas. Alright, so the forces on and the forces on them. Okay, so fluid mechanics can be divided into fluid statics and the study of fluids at rest, or fluid kinematics, the study of fluids in motion. Right, so fluid dynamics and the study of effects of its forces on fluid motion. So fluid mechanics is concerned with the behavior of fluids at rest and in motion. Okay, so distinction between the solids and fluids. So basically, when we say solid, solid is hard, no? So incompressible, right? So sorry, compressible. And when we talk about fluids, incompressible, or it follows the shape of its containers. So according to our experiences, solid is hard and not easy to deform. A fluid is soft and deforms easily. Right? So fluid is a substance that alters its shape in response to any force, however small. Okay? So that tends to flow or to conform to the outline of its container, as I've said earlier, and that includes gases and liquids and a mixture of solids and liquids capable of flow. Alright, so a fluid is defined as a substance that deforms continuously when acted on by a shearing stress of any magnitude. Alright, so let's do historical notes lang, no? Historical notes. So, di naman dyan digikan ang fluid mechanics, no? So, it comes from, it started with Newton, then Mr. Bernoulli, no, Daniel Bernoulli, and Euler. Okay, so design of fluid mechanics began, no, when there is a need to control irrigation purposes in ancient Egypt, Mesopotamia, and India, which also makes sense, nga naman, because in farming we need to irrigate and we need to divert the flow of water, and in order to do that, in order to improve the or to put up an engineering solution in diverting safely the water in these following country or in these following places, for example, we need to study the water itself or the fluids itself, or how does the fluid flows. So that is why it started with Newton, and based on the greatest contribution of Newton's, we have the second law of Newton, where we focuses on fluids, So Daniel Bernoulli and Euler's, these are the basically the notified or most notorious people in the field of fluid mechanics and hydrodynamics, So kana sila. All right, so let's proceed. Okay, and units. Okay, in fluid mechanics, we must describe various fluid characteristics in terms of certain basic quantities such as length, time, and mass. Okay, so a dimension is measured by which a physical variable is expressed qualitatively. Example, length of a dimension associated with distance, width, height, and displacement. So basic dimensions for length, L, primary quantities, time for T, we have mass as M, okay, temperature K, and SI unit, we can derive any secondary quantity from the primary quantities. Example, a force is equal to mass times acceleration. Therefore, F is just equal to M is equal to L, the length, times the time over the time squared, no? So, muna siya. Okay, a unit is a particular way of attaching a number to a qualitative dimension. System of units can vary from country to country, but dimensions do not. Okay? So, dimensions and units. So, basically, we just want to familiarize ourselves with these units, no? With these units. Alright, so, primary dimensions, we have mass, as we established earlier, no? Mass, we have length, the time, temperature, and force. Alright, so usually here in the Philippines, we use SI unit. Right, so we use kilograms, we have meters, second for time, Kelvin for temperature, or usually we use Celsius man, no? And then force, Newton. Okay? And under British gravitational or BG unit, we have slug, foot, second, Rankine, and pound. And under the English engineering unit, we have pound mass. Okay? We have foot, we have second for time, and Rankine as temperature, and pound force, no, for force. Okay, so kindly familiarize yourself with this dimension and unit system. Okay, so SI unit or SI system is based, dimensions are length, time, mass, and temperature. A Newton is a force when applied to a mass of a kilogram produces an acceleration of 1 meter per second square. Okay? So Newton is a derived unit. 1 Newton is basically equivalent to 1 kilogram per meter per second square. So, British gravitational system based dimensions are length, same lang sa taas, no? A slug is a mass produces an acceleration of 1 feet per second or 1 foot per second when a force of 1 pound is applied to it. Okay, slug is derived unit. 1 slug is just equal to 1 pound times seconds squared over 1 foot. Therefore, it is basically 32.2 pound mass. Okay, pound mass. Alright, so English engineering system based dimensions are same as above, no? Length, time, mass, force, and temperature, no? The 1 pound force is defined as the force which accelerates 1 pound mass. Okay, so LDM. Okay, so 32.174 feet per second square. That is the gravitational acceleration in English engineering system. But then again, usually we round this one up into 32.2, in which 32.2 is the most common used value for the acceleration in English engineering system. Alright, so let's proceed. Other basic units, no? For Kelvin, we just need to add 273 in our Celsius reading. And as I've said, here in the Philippines, we usually use Celsius, no? For Rankine, we need to add 460 plus the Fahrenheit. So from Celsius, we need to convert it to Fahrenheit and add 460. No? So basically, that's how you get Rankine, right? So in temperatures. Okay. Mass or weight of fluids. Okay, so we want to talk about mass density also, or raw. Okay, so in fluid mechanics, we usually differ this one as raw, no? Mass density. Okay, so density of, it might be density of a fluid or density of a water, no? So mass per unit volume. Right, so mass density of water is mass density of water at 4% or 4 degrees Celsius is 1,000 kilograms per cubic meter. Well, therefore, it translates in English, no? In English, it translates to us in English unit as 62.4, no? 62.4 pound mass per cubic foot. Alright? So, please take note of these particular values because we are commonly used, or we will be commonly using these values, no? 1,000 kilogram per cubic meter and 62.4 pounds per cubic foot, no, of water. Right? So as mass density. Now specific unit weight, or specific weight, right, or unit weight, the gravitational force per unit volume of fluid, specific weight of water is 20 degrees Celsius is 9.79 kilonewton per cubic meter. But then again, some of the books, for simplification reason, some of which are using 9.8, no, 9.8 kilonewton per meter per cubic meter, no, of water. All right? So basin og malibog mo, no, 9.8. Hala sir, ano 9.8? And if you ask, sir, what should be we using, no? What should be we using when there is an exam, or there is basically an assignment? Basically, you need to use what is specified. No, what is specified. For example, in the problem, it is specified that you need to use 9.81, no, cubic kilonewton per cubic meter, or 9.8 or 9.79, no, kilonewton per cubic meter. So depending on the problem itself, no, just based your solution on the specific weight or specific gravity, specific weight that is provided in the problem. Okay. Specific gravity and specific volume. Alright, so specific gravity, we denote that one as S. Sometimes in some books, no, we refer that one as S sub G or SG. No? The ratio of specific weight of a given fluid to a specific weight of water at a standard reference temperature. Alright, oh, here we go. So this will be our formula. Okay, so unit weight, no, or specific weight, no, specific weight of any fluid, no, any fluid over the specific weight of water. In which case, we already know that the specific weight of water is around, atong balikot, is around, specific weight of water is 9.8 or 9.79, no, 9.8 or 9.79, no, for example. And then for density, no, density of the any fluid over the density of water. Class nga nung, if you ask, no, sir, pag mangita may specific gravity, why should we why would we divide that one with water, no, the specific weight of water, the unit weight of water, and the density of water? It is because, no, water is measurable. It is easy to measure. Okay, so that is why in this fluid mechanics, water is used as the basis, no, as the basis. All right, so for example, any fluid, let's talk about oil, for example, or any oil, or cooking oil, no, o olive oil, o sana oil, sama ka. All right, so anyway, for unit weight or specific weight of oil, no, we generally don't have any. We basically have a table of specific weight for certain types of oil, no, in which case we just wanted to know through the solution, no. So since we want to know, no, the unit weight of, or the unit weight of oil, and we are given a specific gravity, no, specific gravity, what will be the unit weight of oil? Okay, so basically all we need to do is just to multiply the specific gravity with the unit weight of our water in order to determine the unit weight of our oil. So vice versa, no, you can just go ahead and make an algebraic manipulation, no, of depending on what is given and what is asked. So basically, in this specific gravity, no, this is our general formula. Okay? Specific volume. So basically, specific volume, it's just the inversely proportional to density. Okay? So specific volume is just 1 over rho. Okay? So 1 over rho is just our specific volume. Alright, so example number 1. Okay, for example, for these examples or for the examples, I'll be creating another video, no? Just for the examples alone, for the 4 examples, I'll be answering the 4 examples on another video. For this one, no? Thank you very much for listening. Don't forget, no, to learn, enjoy, and have fun. Bye, guys!